Hi, my name is Frank Griffin. I am a Cisco Academy instructor in BlackRock Further Education Institute. In this video, I am going to demonstrate IP subnetting. In order to follow this video, you will need to be familiar with decimal to binary conversion. Okay, so let's start. I will begin with an IP network address of 192.168.10.0 and a subnet mask of 255.255.255.0. IP addresses are made up of two parts, the network portion and the host portion. In the example that I'm using, the first 3 octets are the network portion, and the last octet is the host portion. Okay, so what addresses are available in this network? Well, the first address we've seen is the network address. This address is used to represent the entire network. The network address has a 0 in the host portion. When the host portion is 255, this is the broadcast address. This is the address that is used when you want to send a message simultaneously to all hosts on the network. All of the addresses in between the network and broadcast addresses can be allocated to devices on the network, such as computers and printers. Note the network portion stays the same for all addresses. The host portion can vary. The addresses can also be represented in binary. All zeros in the host portion is the network address. All ones in the host portion is the broadcast address. When there's a mixture of ones and zeros in the host portion, the address can be allocated to a device on the network. Okay, so what is the role of the subnet mask in IP addressing? Well, the subnet mask identifies the different portions of an address. For example, take one of the addresses from our example network, 192.168.10.3. Where there is a 255 in the subnet mask, this identifies the network portion of the address. And where there is a 0, this identifies the host portion of the IP address. Similarly, if I write out the address in binary, a 1 in the binary subnet mask corresponds to the network portion. The zeros in the subnet mask correspond to the host portion of the IP address. In this example, the network portion is the first 3 octets. The host portion is the final octet. So the host portion has 8 bits. The network portion is 24 bits. Subnetting is when one big network is divided into 2 or more smaller subnetworks. The process of subnetting involves changing one or more of the host portion bits in the subnet mask from a 0 to a 1. This creates a new subnet mask and creates 2 or more smaller subnets. For example, I'm going to change one bit in our subnet mask from a 0 to a 1. Currently, the first 24 bits in this subnet mask are 1, which means they represent the network portion. The final 8 bits of the subnet mask are 0. This is the host portion. I'm going to change one bit in this subnet mask from a 0 to a 1, specifically this bit, the 25th bit. Notice that now the network portion extends into the final octet. The 25th bit is now part of the network portion. It is no longer part of the host portion. Also, the subnet mask in decimal is now 255, 255, 255, 128. So our original subnet mask and network address looked like this. I then created a new subnet mask by changing one bit in the host portion from a 0 to a 1. This bit is sometimes called a subnet bit. Here is the bit we changed in the subnet mask, and here is the corresponding bit in the original network IP address. The corresponding bit in the network address can now have 2 values. It can be 0 or 1. When it's set to 0, this is subnet 0, and when it's set to 1, this is subnet 1. So by changing one bit, we've created 2 new subnets. Focusing on subnet 0. The first 25 bits, the network bits, must remain the same for all addresses in this subnet. So the subnet address is when all 7 bits in the host portion are 0. If all the host bits are set to 1, this is our broadcast address. So the broadcast address would be 192.168.10.127. All the addresses in between 0 and 127 can be allocated to devices. We can work through a similar process for subnet 1. Setting all the host bits to 0 gives a subnet address of 192.168.10.128. If we set all the host bits to 1, that gives a broadcast address of 192.168.10.255. So the range of available device addresses is from .129 to .254. So to summarize, we began with this network address and subnet mask. We changed 1 bit in the host portion of the subnet mask, creating a new subnet mask and 2 new subnets.